Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 10, where we will again solve a problem based on stack, and the level of this question is going to be medium. The name of this question is min stack. You will get this question link in description, and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on Leetcode. So this is our question on Leetcode. It says to design a stack that supports push, pop, top and retrieving the minimum element in constant time. So the question is pretty straightforward. It simply says to design a stack in which we can have these operations such as push operation, pop operation, top operation and retrieving the minimum element. Yes, retrieving the minimum element in constant time. So this constant time is very important, right? So it's very simple. We have to make a stack which can have its basic functionality such as push, pop and top, and we have to add one more functionality, that is retrieving the minimum element, right? Retrieving the minimum element from our stack, and it should be done in constant time, right? Now implement the min stack class. So this is the min stack class, and we have to implement this class. So we have a constructor min stack which initializes the stack object. This is our constructor. Then we have a function named as void push, and it takes a value, integer value, and what it does, it pushes the element val onto the stack. So this is the function. It is a very simple push operation. Whatever value we are getting, we just need to push it into our stack, right? Then we have a void pop operation or a void pop function which removes the element which is present on the top of the stack. So again, this is very simple. We just have to remove the element which is present on the top of our stack. Then we have int top gets the top element of the stack. So this is also very simple. We have a function named as int top. So what it will do, it will just return the element which is present at the top of our stack, right? Then we have int get min. This is again a function. It retrieves the minimum element in the stack. So this is one of the very important functions which we have to implement. What it does, it just returns the minimum element which is present into our stack, right? And you must implement a solution with O of 1 time complexity for each function, right? So for every function we have to write a code, and the time complexity for each function should be O of 1, or you can say constant time complexity, right? Now if you will scroll down, so in the constraints, the second point is very important. It says that methods pop, top and get min operation will always be called on non-empty stacks. So this is very important. Pop operation, top operation and get min operation, these methods or these functions will always be called on a non-empty stack. Now let's analyze our problem by taking some examples. So firstly, let me just create a stack. Okay, so let's say this is our stack and we are getting different operations, such as we get one push operation which says to push 12 into our stack. Then we will simply push 12 into our stack. Let's say the next operation is to push 13 into our stack. Then we will push 13 into our stack. And the next operation is a top operation. So we have to return the element which is present at the top of our stack. So the element which is present at the top is nothing but 13. So we will simply return 13 for this particular operation. Now let's say the next operation is get min, right? Get min. So for this particular operation, we have to return the minimum element which is present into our stack. So we can clearly see that the minimum element is nothing but 12. So we will return 12 for this particular operation. So now let's say the next operation is again a push operation of 2. Then we will push 2 into our stack. And then the next operation is top. So the element which is present at the top of our stack is nothing but 2. So we will return 2. Now let's say the next operation is get min, right? So we know that the minimum element present into our stack is nothing but the 2 itself. So we will return 2 again. right? Let me just remove this. Okay, now let's say the next operation is a pop operation. That what we will do, we will pop out this 2, right? We will just pop out this 2 from our stack, so we'll just remove it. We will remove it. Now let's say the next operation is the top operation, so we'll return the element which is present at the top. It is nothing but 13, so we will return 13. Now again, let's say we got this operation, that is get min. So the minimum element which is present into a stack is nothing but 12, right? So we'll again return 12. We will again return 12. Now let's say the next operation is again a pop operation. Then what we'll do, we will remove this 13 from our stack, right? We will remove this 13 from our stack. So now if the question says to get the minimum element, now what is the minimum element? We have just one element present into our stack, so this will be our minimum element. So we have to return 12 for this particular operation. So I hope this is clear, that what we are doing with the push operation and with the top operation, with the get min operation and with the pop operation, right? Now let's think about how we are going to solve this particular problem, right? Okay, let's think about how we are going to solve it. Now the very first approach or very first thought which comes in our brain when we see this question is, we can maintain a variable named as mini, which will store the minimum element, right? Which will store the minimum element which is present into our stack, right? And whenever we get this operation, whenever we get this get min operation, then we will simply return our mini variable, because it will hold the minimum element which is present into our stack. But there is a problem with this particular approach. Let's analyze what is the problem, then we will probably think about how we are going to solve it. Okay, so let me just create the stack first. Okay, so let's say this is our stack, right? Let's say this is our stack, and again we are getting different operations, but before that we will have a variable named as mini, and the initial value which will be stored into a mini variable will be a very big value, or you can say infinite, and we will get different operations. So let's say first we have a push operation, of 12, right? Then what we will do, whenever we get this push operation, so this 12 is nothing but the value which we have to put into our stack. Then what we will do, we will just push it simply into our stack. So I just push 12 into my stack, and after putting 12 into my stack, I will update my mini variable, right? I will update my mini variable. I will compare this particular value with the value which is stored in my mini variable. So if this particular value is lesser than my mini, then I will say mini is equal to val, right? So what does it mean? It simply means that, right, if I am inserting a value, which is lesser than my mini variable, then I will simply update my mini variable, right? This is the basic logic. So we will compare what is the value is 12, and what is the value present in our mini variable, it is infinity. So is this 12 is lesser than my infinite, right? Is this 12 is lesser than infinite? You will say yes. Then we will just update our mini variable. And we will write 12 here, right? And we will write 12 here. So I hope this is clear. Now let's say we again get a push operation which says to push 8, into our stack. Then what we will do, we will simply push this 8 into our stack, right? This is our first step, right? Now we are done with the first step. Then what we will do, we will compare it with our mini variable. So what is the value? Value is nothing but 8. We will compare, is this 8 is lesser than 12, because 12 is something which is stored into our mini variable, right? So is this 8 is lesser than 12? The answer is yes, 8 is lesser than 12. And if it is lesser than 12, I will just update my mini variable. So I will store 8 in my mini variable. So I hope up to this point this particular approach is clear. Okay, now let's say the question says to find the minimum element, right? Let's say the question says to get the minimum. Then what we can do, we can simply return, we can simply return our mini variable, because my mini variable holds the minimum element which is present into my stack, which is nothing but 8. So it will return 8, and up to this point this particular approach is clear, right? So let me just take it down. Okay, so let me just take it down so that I will get some more space. Okay, yeah. So now let's say the next operation is to push 2, right? To push 2 into our stack. Then what we'll do, we will push 2 into our stack, and then again we will update our mini variable. So the current value is 2. Is it lesser than the value which I have in my mini variable? So in my mini variable I have 8. So is this 2 is lesser than 8? The answer is yes, of course. Then what we will do, we will just update our mini variable and we will write 2, or we will store 2 into our mini variable, right? After doing this, let me just rub this. Now after doing this, let's say we have a pop operation. We got one pop operation. Then what we will do, this is very important, right? This is very important. So all your focus should be here, right? All your focus should be here. Now let's say we have a pop operation. Now what does pop operation do? What it will do, the element which is present at the top of our stack, it will remove it from our stack. So we will remove this particular 2 from our stack. So we have just removed this. Now this is the point. Now let's say we got the other operation which is get min, right? Now we got the operation which is get min. So as per our approach, whenever we were getting this get min, what we were doing, we were just returning the mini, right? We were just returning the mini variable, and into our mini variable we have 2. So we will return 2, but this is wrong. Why this is wrong? Because this 2 is not present into my stack. If this is not present into my stack, then how you can say that this is the minimum element? And of course, if you see this stack, then the minimum element is 8. Minimum element is not 2. So this is the point where this particular approach gets failed, and now we have to think about the other approach, right? So what was the problem we were facing in this particular approach was, let's say our mini variable holds 2, right? It holds 2, and we have 8, 9, 2, right? And this 2 is also our top element, right? And this 2 is also our top element. Now if I have this pop operation, then this particular 2 will be removed. It will be taken out from our stack. And it will be taken out, but still this mini will hold this value 2, right? And this is wrong. So we have to think about something. We have to think of something through which, whenever we are doing a pop operation, we are getting the right minimum element, right? We should get the right minimum element. So how we can do this? So the approach is, or you can say the intuition is, we should hold the minimum value. Up to each operation into our stack, right? We should hold the minimum value up to each operation. Now what does I mean by each operation? Let's see this again. Okay, so let's say that we have one push operation which says to push 12. I will push 12. Then we have a push operation which says to push 7. I will push 7. Then I have another push operation which says to push let's say 2. Then I will push 2 here. Now my mini is nothing but this 2. Okay, but if I remove this 2, if I just remove this 2 from my stack, then what will be my minimum element, right? So what I am trying to say, before this 2, what was our minimum element? Into our stack? It was nothing but the 7. So in this way, we should have the value, right? We should have the value of the minimum operation, of the minimum value for each operation. We should update we should update this mini variable with each operation, right? With each operation. So how we are going to do this? Let's see this. So this particular approach is also very simple, and you will understand it as I will do a dry run. So let's say this is our stack, right? Now this stack will hold two values, right? It will hold two values. Very first one is the current value, and second one is the value of the current minimum element, right? This mini will hold the value of the current minimum element, right? Current minimum element. Okay, now let's say we got one operation which says push 12 here, right? So what we will do, we will push 12 into our stack, and what is the current minimum? What will be the current minimum? So see, this is what? This is our first element into our stack, right? This is our first element into our stack. Then what will be the minimum? Minimum will be this 12 itself, because it is the first element. So we will push 12, right, into this stack. Now the first 12, right? The first 12 says that this is the top element, right? This is the top element which I have into my stack. And this second 12 says that this is my current minimum, right? The second value says that this is my current minimum. So I hope this is clear. Now let's say we got one next push operation which says to push 8 into our stack, right? It says to push 8 into a stack. So before pushing it, let me just remove all this. Let me just rub this. Okay, then what we will do, what is the value? Value is 8. So I will just push 8 into my stack. What this 8 signifies? This signifies that the top element present into my stack is nothing but 8, right? And what will be my second value? See, second value has to be the current minimum element. So if I have 8 and 12 into my stack, then what will be the minimum element? Yes, you guessed it right. The minimum element is nothing but 12 itself. So we will put 12, and it says that this is the current minimum. This is the current minimum. Now let's say the next operation is push 15, right? Let's say the next operation is nothing but push 15. Then what we will do? We will push 15, right? We will push 15 into our stack. So we will push 15 into our stack, right? Now what does this 15 signifies? It says that this is nothing but the top element which is present into my stack, right? What will be present here? Because what we are storing in the second value, it is nothing but the current minimum element of our stack. What is the current minimum element into our stack? So see, right now we have 15, we have 8, we have 12. What is the minimum element? Minimum element is nothing but 8 itself, right? So we will push 8 here, right? We will push 8 here. And what does this 8 signifies? It signifies that this is the current minimum element. This is the current minimum element. Now let's say question says to push 6, right? Question says to push 6 into our stack. Then what we will do? We will simply push 6, right? We will simply push 6. So we will write 6 here. Now what do I need to write here, right? What do I need to write here? Very firstly, what is the value which we are storing at this position? It is nothing but the current minimum element of our stack. It is nothing but the current minimum element. Okay, so right now we have 6, we have 15, we have 8, and we have 12 into our stack. If I ask you what is the minimum element, then you will say the minimum element is nothing but 6 itself. Then what we will do? We will put 6 here, correct? We will put 6 here. Okay. Now let's say the next operation is nothing but top. What we will return? We will return this particular 6. We will return this particular 6 because this is the element which is present at the top of our stack. Now if the question says to get the minimum, then what is the minimum element present into our stack? Yes, the minimum element is nothing but this 6. So we will return 6, right? Now again, your attention should be here. If the question says to do a pop operation, right? If the question says to do a pop operation, then what we will do? We will simply pop this out from our stack, right? after popping out, my stack will look like this. My stack will look like this. Now if the question says, if I get the next operation to find the top, what is the top element? Top element is nothing but 15, right? Now if the question says to get the minimum element, then what is the minimum element? Minimum element is nothing but 8 itself. So I will return 8. So now I hope the problem which we were getting with this particular approach, right? The problem which we were getting with this particular approach when we were holding a mini variable and we were returning the mini variable, this particular problem is solved, right? This particular problem is solved here, and this is going to be a good solution, or you can say a perfect solution. So this is our approach, this is our intuition, what we are going to use, what we are going to code. So very firstly, what we thought of maintaining a mini variable, but the mini variable, the problem was whenever the minimum element were present at the top, right? Whenever the minimum element was present at the top and we were doing a pop operation, we were taking this minimum element out from our stack, and if I again try to find out what is the minimum element, then in the minimum element it hold the previous minimum value, which was 2. So this minimum variable was not updating for that particular case when the minimum element was present at the top of our stack and we were doing a pop operation. So this particular problem was solved with this particular approach. And what we are doing in this particular approach, we are updating the value of our mini or our minimum variable for each operation, right? For each particular operation. So I hope this particular approach is clear into your mind. Now let's think of how we are going to code this up. So very firstly, what we will use, we will have a stack, and inside the stack we will use a pair of int comma int, right? And let's say the name of the stack is st, right? Where the first int is nothing but the top element and the second int is nothing but our current minimum, right? But our current minimum element. Okay, so now let's do a void push operation. Here we will get the value, right? So what we need to check, right? So very firstly, I need to check that is my stack is empty or not, right? So if my stack is empty, right? If my stack is empty, it means that this value is nothing but the first element which I am storing into my stack. So by default it will be my minimum value as well, right? By default it will be my minimum value as well. So what I can do in this scenario, I can just simply do st dot push val and val, right? So this particular value will be my minimum value, right? And it will be the value which is present at the top also, right? I hope this is clear. If this is not the case, it means that we have something into our stack and now we are pushing another element. So we have to kind of update our mini variable as well. So let's say we are creating a minimum variable, let's say int mini. It will be nothing but the minimum, of the current value which user is storing into our stack and the previous minimum. So how we'll get the previous minimum? It will be very simple. We'll write st dot top dot second, right? st dot top dot second, because the st dot top will give me this particular element, this particular value, sorry. And from this particular value I have two values, 15 and 8, where this 15 is the first element and this 8 is my second element, right? Whenever I say I want the minimum element, so now I am talking about this second element. This is second element, which is 8. Therefore I have written here st dot top dot second. Now I just need to push it. So I will do st dot push the value and the minimum value, right? So this is what we will push, right? So this is our push operation, and if you see it clearly, then the time complexity will be O of 1. Correct, the time complexity is going to be O of 1. So yes, we are implementing this particular function in a constant time complexity. Now let's say we have another operation which is int top, right? Int top. So when the users, so see, whenever we get this top operation, what we have to do, we have to return the element which is present at the top. So what we'll do, we will return st dot top dot first, right? As simple as that. I know the spelling of return is incorrect, return, return, right? So this is the only one single line of code which I have to write in this top operation, because let me just rub this so that it will be more clear to you. Okay, so when I do st.top, I will get this particular element, right? I will get this particular element, I will get 15 and I will get 8. Now if the question says to get the minimum element, right? Now if the question says to get the minimum element, I will return this, which is my second. Or if the question says to get me the top element, I will return this, which is my, not second, which is my first, so I will return this, right? That's the reason why I am returning this first. And here also the time complexity is big O of 1. If the next operation, let's write the next operation, which is void pop. So with the pop operation, what we are doing, we are just popping out the element which is present into our stack at the top. So we just need to do this st dot pop, and again the time complexity for this particular operation is also going to be O of 1. Now the very important function, if question says int get min, right? Now when we have to implement this get min operation, what we will do, we will just return st dot top dot second, right? Dot second. This is the single line of code which we need to write, and the time complexity will be big O of 1, which is constant time, right? Which is constant time, because whenever I do st dot top, I will get this value, I will get this pair which will hold the top element and it will also hold the minimum value, right? So whenever user says to find out or to give me the minimum value, I will return the second, value, second element into from my pair. And if the question says to get the top element, I will return the first element from my pair, right? So I hope this is clear. And the time complexity for each operation is O of 1, which is constant. And if we talk about the space complexity, then the space complexity is going to be near about O of n, right? It is going to be near about O of n, or you can say O of 2n, because in the stack we are storing two values, right? We are storing two values. We are storing a pair of int and int. So you can say that probably the time complexity is big O of 2n, which is approximately equal to big O of n. So I hope this particular approach is clear, the intuition is clear. Now let's fastly code it up on Leetcode. So now we are here on Leetcode. Very firstly, what do we need? We need a stack. So we will make a stack which will hold two values in form of pair, and let's say the name of our stack is nothing but st. So right now we do not have to do with this constructor, right? Now let's talk about this push operation. Whenever we are pushing, firstly we have to check that is my stack is empty, right? Now if my stack is empty, then the minimum element will be this value itself. So I can just simply do st dot push val comma val, right? Because the top element will be val and the minimum element will also be val, right? Because it is the only one element which is present into my stack. Then I will do else, right? If this is not the first element, right? If this value is not the first element which we are going to store into our stack, then we need to calculate the new minimum. So I can write int mini, and it will be equal to minimum of the value which I am getting, and st dot top dot second, right? Now I'll simply do st dot push the value and the minimum element, right? So I hope this is clear. and whenever we are doing a pop operation, I just need to write st dot pop. Whenever we are doing a top operation, we just need to write return st dot top dot first, and when we are doing the get min operation, we just need to return st dot top dot second, right? Because the element, the second element into our pair will be nothing but the minimum element, right? The first element into our pair is going to be the element which is at the top of our stack, and the second element is nothing but the current minimum, right? So let me just write it as C mini, right? Current minimum. So when the question says to get the minimum, we will do st dot top dot second. So here we will not have this parenthesis, right? Now when question says to return the top element, we will do st dot top dot first. So I hope this particular approach is clear. Let me just run this. Okay, so you can see that all the 2 sample test cases are running fine. Let me just submit this. So now you can clearly see that this particular solution is accepted. So this was all for this day, and here we solved again a problem based on stack. I hope you like this video. If this video was helpful to you, please do a comment, like this video, and make sure you subscribe to this channel so that you get this type of content regularly. And we will meet again tomorrow with a new question.